Hello everyone, I am Peter B Adattu. I am currently a third year engineering physics student at IIT Roorkee. I am here to do a small presentation on the topic 3D printing. What is 3D printing? 3D printing is a revolutionary form of manufacturing, enabling the creation of three-dimensional objects by building them layer by layer from various materials, often referred to as additive manufacturing, not like the traditional separative methods, which involve cutting away material from a solid block. One of the key advantages of 3D printing is its ability to rapidly prototype designs. Another term often used interchangeably with 3D printing is rapid prototyping. So this highlights the technology's ability to swiftly produce physical models directly from digital designs. So now the steps involved in 3D printing. The first step in 3D printing is designing the object you want to print in a digital 3D model. This can be accomplished using specialized software such as computer-aided design or 3D modeling software. Once the design is complete, the 3D model is sliced into thin horizontal layers using slicing software. These layers are like virtual cross-sections of the object and serve as instructions for the printer. The thickness of these layers impacts the final resolution and detail of the printed object. Step 3 is printing. The printer reads the sliced data and begins building the object layer by layer. Various 3D printing technologies exist, but they all follow the same basic principle of depositing material layer by layer and fusing them together to form the final object. Step 4, material deposition. The type of material and deposition method used depend on the 3D printing technology. The common methods include fuse deposition modeling, FDM, stereolithography, SLA, and selective laser sintering. Fuse deposition modeling is a widely used and affordable 3D printing technology. It involves feeding plastic filament through a heated extruder nozzle, melting it, and depositing it layer by layer to form objects. Common materials used are ABS, acrylonitrile, butadiene styrene, PLA, polyacetic acid, and PETG, polyethylene terephthalate glycol. Stereolithography SLA. SLA is an additive manufacturing process where objects are created layer by layer using liquid resin solidified by UV light. A laser selectively hardens the resin based on the digital design, resulting in precise physical replicas. Selective laser sintering (SLS). SLS utilizes a powerful laser to fuse powder particles layer by layer. The powder bed is lowered after each layer, and a new layer of powder is spread across the top. The laser selectively sinters the powder particles based on the slice model data until the entire object is constructed. The step 5 in 3D printing is layer bonding. As each layer is deposited, it bonds to the previous layer through processes like melting, curing with a laser, or using an adhesive. This layer by layer bonding process continues until the entire object is built. Step 6 is post processing. After printing, the object may require post processing steps depending on the technology used. This could involve removing supporting structures, cleaning excess material, or applying surface treatments to achieve the desired finish. So let's dive into the application side of 3D printing. Manufacturing. So 3D printing is revolutionizing traditional manufacturing processes by enabling rapid prototyping, customized tooling, and on-demand production of end-use parts. In the field of medicine, 3D printing is making remarkable strides, allowing for the creation of prosthetics, implants, and even bioprinted tissues and organs. The aerospace industries are leveraging 3D printing to produce lightweight and complex parts for airplanes and spacecraft, leading to improved efficiency and performance. In construction, 3D printing is being explored for its potential to build structures with intricate designs and reduce material waste, paving the way for sustainable building practices. The capacity of 3D printing to produce uniquely tailored items according to individual preferences is unlocking fresh opportunities in consumer goods spanning from customized accessories to personalized furniture. 3D printing is transforming education by providing hands-on learning experiences and empowering students to bring their ideas to life through design and fabrication. In the realm of food, 3D printing is pushing the boundaries of culinary innovation, allowing chefs to create intricate designs and personalized dishes with edible materials. Fashion designers are increasingly adopting 3D printing as a means to craft cutting-edge apparel, footwear, and accessories, facilitating unparalleled levels of innovation and personalization. Now we go into the advantages of 3D printing. First one is the design flexibility. One of the key advantages of 3D printing is its unparalleled design flexibility, allowing for the creation of highly intricate and unique shapes that would be challenging or impossible to achieve with the traditional manufacturing methods. Rapid prototyping. So 3D printing enables rapid prototyping, significantly reducing the time and cost associated with the traditional prototyping processes. This accelerates the design iteration cycle, leading to faster innovation and product development and print on demand. So with the 3D printing, products can be produced on demand, eliminating the need for large inventories and reducing storage space requirements. This on-demand manufacturing approach enhances supply chain efficiency and reduces overhead costs. Strong and lightweight parts. 3D printing allows for the creation of parts that are both strong and lightweight, making them ideal for applications in industries such as aerospace, automotive, and consumer electronics. So then minimize waste. So unlike subtractive manufacturing methods that generate significant waste, 3D printing is an additive process that generates minimal material waste. Then cost effective. So 3D printing can offer cost savings compared to traditional manufacturing methods, particularly for low volume production runs or highly customized products. Then environment friendly. The additive nature of 3D printing and its ability to minimize material waste contribute to its environment friendliness. So in conclusion, 3D printing represents a revolutionary shift in manufacturing, offering unparalleled capabilities for rapid prototyping, customization, and the realization of complex designs. Advancements in materials and technologies are continually expanding the applications of 3D printing across diverse industries, including aerospace, healthcare, and automotive. Looking ahead, the future of 3D printing holds tremendous promise. Innovations such as bioprinting organs, multi-material printing, and sustainable manufacturing practices are on the horizon. So these advancements have the potential to revolutionize healthcare by providing personalized medical solutions, enhance product performance in aerospace and automotive industries, and promote environmental sustainability. As we embrace these exciting possibilities, it's clear that 3D printing will play a pivotal role in shaping the future of manufacturing and ushering in a new era of innovation and sustainability. Thank you for joining us on this journey through the transformative potential of 3D printing. Together, let's continue to explore, innovate, and harness the power of additive manufacturing for a brighter future.